Here we're going to solve for some gas stoichiometry. So it's just like the stoichiometry we've done in the past, but now we're going to have some gas laws involved, and so it becomes a little bit harder. But there are 3 steps to stoichiometry. The first step is to convert to moles. And so what we have here is we want to know how many grams of sodium azide goes into an airbag to produce 30 liters of nitrogen gas. And so we need to convert 30 liters to moles. Now there's a couple of ways to do it. I'm going to do it kind of the longer way that's more general. And to convert liters to moles of a gas, we need PV equals nRT. And so we're going to go ahead and set up that equation over here. P equals V equals N equals R equals T equals. And so that's not going to give us grams of sodium azide, but instead it's going to give us moles of nitrogen gas. And moles of nitrogen gas will help us to convert to grams of sodium azide. So here's STP. STP means standard, so I'm going to use 1 ATM. I could choose any of the 3 as long as I have the R unit that corresponds to it. In this case, 0.821 ATM liters per mole Kelvin. My volume is given to me at 30 liters. My moles is my unknown, and my temperature is standard temperature, which is 273 Kelvin. And so I solve for N equals PV over RT. That's just rearranging PV equals nRT, solving for N. I'll plug in those numbers. 1 times volume over R over T. Give me a moment to type in those numbers. N equals 1.34. Moles, and the units here really matter, moles of N2. And so all this was for the one part of stoich to convert to moles. And so I'm going to start over here, 1.34 moles of N2. X line, drag down the unit. We're trying to get to sodium azide. So before I convert to grams of sodium azide, I have to convert to moles of sodium azide. And using the balanced equation, it's 1 to 1. This is not balanced yet, so let's go ahead and do that. 3 times 2 is 6, 2 times 3 is 6, and 2 sodiums, 2, 2, 3. Now that we have that, now we can really take this 2 to 3 using those coefficients. X line, drag down the unit. Sodium azide, moles of sodium azide to grams of sodium azide. The molar mass for that would be 1 sodium and 3 nitrogens, 65.011 grams per 1 mole. Again, 1 mole is equal to the molar mass in grams. And so we type that into our calculator, and we get the correct answer. The proper sig figs, again, 3 being 3 sig figs. I get 58.08, that rounds up to 58.1 for 3 significant figures. And so the stoichiometry is always 3 steps. First step is converting to moles. Second step is using the mole ratio. And the third step is convert to desired unit. So all of this was just one step of converting to moles. There is a shortcut that you can use at STP using 22.4, but that's liters per mole. That's only good at STP, so the more general use is to use the PV equals nRT. Now, it's not always going to be PV equals nRT first. Sometimes PV equals nRT is going to be last with gas stoichiometry. You have to think about what unit you have. There's a temptation to make this N over here moles of sodium azide because that's what I'm working for, but it's given to me clearly as nitrogen gas. I'm not going to ignore those words. So this is nitrogen gas, so I need to use the mole ratio to convert nitrogen gas to sodium azide, and then use the molar mass to convert sodium azide moles to grams of sodium azide. So this problem over here is giving me grams, so I have to go grams to moles of KClO3. Moles of KClO3 to what it's asking for, oxygen, so moles of oxygen and then liters of oxygen. So here the PV with NRT will be last, and the molar mass will go first, and molar ratio is still second. So it's not a matter of first is PV equals NRT, second is molar ratio, third is molar mass. Sometimes it can be just the opposite depending on what I ask you. And this time I asked you grams, this time I give you grams. First time I gave you liters, the second time I asked you for liters. That's why everything is backwards, but the three general steps are still the same. First, convert to moles. Second, use mole ratio. Third, convert from moles to the desired unit. So as best you can, make that happen. And so I'm going to put that to words again. First, convert to moles. That's really sloppy, my apologies. Convert to moles. Second step, mole ratio. Third step, convert to desired unit. So number one, the desired unit was grams. Number two, the desired unit was liters of oxygen. And so each time can be different. Each time what's given to you could be different. But these three steps are going to be very, very consistent. Thank you.